Welcome back. This is Ms. RRubright with Advanced Geometry. Today's lesson is on 8.1, Find Angle Measures in Polygons. If you like our videos, please subscribe. So the first thing that we're going to go over is different polygons and what they are named. So if we have a five-sided shape, it is a pentagon. 5 sides is a pentagon. 6 sides we call a hexagon. 1, 2, 3, 4, 5, 6. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 is a nonagon. 10 is a decagon. 11, it doesn't have it up here, but it is a hemdecagon. And then 12 is a dodecagon. We don't really care about 11 for some reason. And anything beyond 12, we just do the number dash gone, hyphen gone. So if it's beyond 12, we just say 13 gone, 256 gone, 869 gone, like whatever the number is, gone. So now, what is the difference between concave versus convex? So concave is where it's like caving in. So a shape that goes like this, it's caving in right here. Do you see how it's caving in? Whereas opposed to this pentagon, everything's pushing outward. So this is a convex pentagon. This is a concave pentagon. The roof is caving in. So right here, convex or concave? Convex, good. Concave, it's caving in right there. Concave. Convex. Concave here and here, right? So it's concave. Concave, it's caving in here, here, and here. How about this one? Concave, it's caving in these 4 corners. What would be the 4 corners? All right, so now that you know a little bit about convex versus concave, I want you guys to copy this down so that you know everything, how to name any polygon. So I'm going to pause this video and you can do the same so that you can copy this down. All right, you guys should be done copying this down. So in addition to these shapes, there's also 3 sides is a triangle and 4 sides would be a quadrilateral. Find the sum of the measures of the interior angles of a convex octagon. So if you go and think back to middle school, on your middle school reference sheet, you guys learned that the sum of interior angles of a polygon is n minus 2 times 180, where n is the number of sides. N minus 2 times 180, where n is the number of sides. So let's look at this is a octagon. Octagons have how many sides? 8. So 8 minus 2 times 180. 8 minus 2 is 6, and 6 times 180 is 1080. So 1080 degrees is the sum of interior angles of this octagon. The sum of the measures of the interior angles of a convex polygon is 900 degrees. Classify the polygon by the number of sides. So if it adds up to 900 degrees equals n minus 2 times 180. What minus 2 times 180 gives you 900? Well, we're going to divide out the 180 on both sides first using opposite operations to isolate the n. So 900 divided by 180, or 90 divided by 18, because you can cancel out those zeros, right? You're going to get 5. 18 goes into 90 5 times. 5 equals n minus 2. So now I'm going to add 2 to both sides to get rid of that minus 2, because we don't want n minus 2, we want n. Now n's by itself, n equals 7, a 7-sided object. And a 7-sided object is a heptagon. The coin shown is in the shape of a regular 11-gon, a hendecagon. Find the sum of the measures of the interior angles. So 11 minus 2, what is 11 minus 2? That's 9, and 9 times 180. When you do 9 times 180, you should get 1,620. The sum of the measures of the interior angles of a convex polygon is 1,440. Classify by number of sides. What minus 2 times 180 is 1440. Divide by 180 on both sides. And you get 8. 8 equals what minus 2? Add 2 to both sides. 10 equals n. It is a 10-sided object. It is a decagon. Find the value of x in the diagram shown. So first off, what are the sum of interior angles? This is a quadrilateral. Let's first think about how this formula came about with the n minus 2 times 180. If I took a quadrilateral and I made it into triangles, I would have 2 triangles, and the sum of interior angles of a triangle is 180. So 180 times 2 is 360. The sum should be 360. Well, let's think about this. 4 minus 2 is 2. 2 times 180 is 360. What if I had a pentagon? How many triangles make up a pentagon? 1, 1, 2, 3, where the sum of these interior angles, all the interior angles of the triangles are covered in the interior angles of the pentagon, 3 of them. 180 times 3 is the sum of interior angles of a pentagon. So 5 sides makes up 3 triangles. So if we had 8 sides, 1, 2, 3, 4, 5, 6, 7. All right, what did I just make? 3, 4, 5, 6, 7, 8. 8 sides. How many triangles do you think we're going to make up? I drew this well. Sorry, it's kind of 1, 2, 3, 4, 5, 6. Wow, so it's always the number of sides minus 2 is the number of triangles that you can draw, and that's where the formula came from. So these are supposed to add up to 360. So then all you do is 360 minus 108 minus 121 minus 59, and you will get your missing angle of 72. So on this one, in the diagram at the right, find the measure of angle S and angle T. How many sides? 1, 2, 3, 4, 5. 5 sides makes 3 triangles. 3 times 180, right? 5 minus 2 is 3. 3 times 180 is 540. This should all add up to 540. 540 minus 93 minus 156 minus 85 leaves you with 206. Angle T and S combined has to equal 206, and they're marked as being congruent. 206 divided by 2 is 103 each. The measures of 3 of the interior angles of a quadrilateral, 3 out of the 4, are as follows. Find the 4th interior angle. All quadrilaterals, 4. 4 minus 2 is 2. 2 times 180 is 360. They always add to 360. 360 minus 89 minus 110 minus 46 equals 115. So the answer is 115. Now you're going to ask, how do I show my work? How do you show your work? You go 360 minus 89 minus 110 minus 46 equals 115, and that shows us what you did. What is the value of x in the diagram shown? So this one's dealing with exterior angles. So with your interior angles, the sum of interior angles is n minus 2 times 180. The exterior angles is always 360 degrees divided by the number of angles. Right? The sum of it, or sorry, not divided by the number of angles. If it's all equal, if it was a regular shape, then divided by the number of angles would give you the measure of each individual angle. But if it's just any exterior angles, it's just they always add to 360. They will always add to 360. So 2x plus 1x is 3x. 3x plus 67 plus 89 is 156. And that all equals 360 because exterior angles always add to 360. The sum of exterior angles will always be 360. 360 minus 156 is 204. So 3x equals 204. Divide by 3 on both sides. X is 68. So this angle right here is 68, where this one is double that, 136. What is the value of x in the diagram? 68. A convex hexagon has exterior angles with measures of 34, 49, 58, 67, and 75. What is the measure of the exterior angle of the sixth vertex? So 360 minus 34 minus 49 minus 58 minus 67 minus 75 leaves us with the sixth angle being 77 degrees. A trampoline shown is shaped like a regular dodecagon. Dodecagon. How many sides is a dodecagon? 12. Find the measure of each interior angle. So first, interior angles of a dodecagon, 12. What is the sum of interior angles of a 12-sided object? Well, 12 minus 2 times 180. 10 times 180 is 1800. If it's regular shape, a regular shape has all equal angles, all equal sides. All equal angles, all equal sides. So you take your 1800 divided by the 12 of them, and they're 150 degrees each. All right, well, what about this exterior angle? Your sum of your exterior angles. So if I look at this exterior angle down here, if this is 150 in here, what's my exterior? Think about it. Straight lines add to 180, so shouldn't it be 30 each? What is 360 divided by 12 equal angles? 30 each, right? Your interior angles and your exterior angles better add up to 180 because they are a linear pair. They will always add to 180. Oops. Okay, your interiors and your exteriors better be a linear pair. They better add to 180. They need to be complementary. An interior angle and an adjacent exterior angle of a polygon form a linear pair. How can you use this fact as another method to find the exterior angle measure in example 5? So you could have just done 180 minus 150 is 30, or the other way is 360 divided by 12 is 30. So you had two methods to be able to solve for that exterior angle. And that is everything on our 8.1, Finding Angle Measures in Polygons. I hope you guys enjoyed this lesson. Stay tuned for our next lesson on 8.2.